Hello and welcome to this Summer 2023 practice paper. This one's for AQA Foundation Paper 1. If you want to give the paper a try first, you can find a link to it in the video's description. You may also want to check out my website where you can see many other practice papers along with the dates for future practice papers that I'll be publishing this year. In this first question we're asked to write 7/10 as a decimal. The answer is 0.7. If you remember, the 0 here is in the units column, and this 7 here is in the tenths column, so it makes sense that this is 7/10. Next we need to write 9% as a decimal. To convert a percentage to a decimal, you just divide it by 100. So we need to do 9 divided by 100, which gives you 0.09. For this question we need to solve an equation. It's 2m equals 14. To solve this one, we'll divide both sides by 2. If you divide the left-hand side by 2, you end up with m, and the right-hand side by 2, you end up with 7. So the solution is m equals 7. For this next equation, we've got 2 plus p equals 14. To solve this one, we're going to subtract 2 from both sides. If you subtract 2 from the left, it will cancel the 2 that's already there, so you're left with p. And if you subtract 2 from the right-hand side, 14 take away 2 is 12. So we end up with p equals 12. This question is testing order of operations, so we need to start with the multiply since that comes before adding. So if we do 21 times 3 first, we can do this by writing it out in a column like this. We'll start with 3 times 1, which gives you 3, and then we move on to 3 times 2, which gives you 6, so that's 63. So now we know that 21 times 3 is 63, so we've got 5 plus 63, which gives you 68. We can do this question in two parts, so let's begin with 4.7 plus 3.5. To do this, we'll do 7 add 5, which gives you 12, so we put a 2 and carry a little 1, and then 4 add 3, which gives you 7, but add that 1 gives you 8, so this is 8.2. Then we need to subtract 0.8, so 8.2, subtract 0.8. First of all, we have 2 take away 8, but we can't do that because we go into negative numbers. So instead we cross this 8 out, replace it with a 7, and steal one of those units, and make it 12 on the tenths column. So 12 take away 8 gives you 4, and then we move on to the next column, so here we have 7 take away 0, which is 7. So we end up with 7.4. In this question we're looking to simplify by collecting like terms. The 5h subtract 2h, they're both like terms, so 5h take away 2h is 3h. And then we've also got this 7 take away 2, they're like terms, and 7 take away 2 is 5, so plus 5. So the answer is 3h plus 5. In this question we have Nicholas who has £3, but he only has 20p coins, so we need to work out how many 20p coins you'd need to get £3. Well, 5 20p coins would be £1, and then every extra pound will be another 5 20p coins, so £2 will be 10 20p coins, and £3 will be 15 20p coins. So Nicholas must have 15 20p coins. Then we move on to Pedro. Pedro has £5.50, but only 50p coins. So 2 50p coins will make £1. So if we want £5, we'll need 5 times as much as this, so 10 coins. So £5 is 10 50p coins, but we want £5.50, so we need an extra 50p coin, so that must be 11 50p coins. So Pedro must have 11 50p coins. Now the question asks us how many coins do they have in total. So we have 15 coins and 11 coins, and if you add those together, you end up with 26 coins. In this question we need to write down the fraction that's shaded. So first of all let's count the shaded squares. We have 1, 2, 3, 4, 5. There are 20 squares in total, we're told that at the start of the question, so the shaded is 5 out of 20. Now the question does also ask us to give our answer in simplest form, so we need to find a number that divides into 5 and 20. Now that would be 5. So let's divide them both by 5. 5 divided by 5 gives you 1, and 20 divided by 5 gives you 4. So the simplest form answer is 1/4. For this part of the question we need to give the answer as a percentage, so let's count the squares once again. We have 1, 2, 3, 4, 5, 6, 7 shaded this time. So if we write that as a fraction, it will be 7 out of 20. But we're asked for a percentage, so instead we'll try and convert this fraction so it's something out of 100. To do this we multiply by 5, 7 times 5 gives you 35, and then on the bottom multiply by 5 gives you 100. So if the fraction is 35 out of 100, that's the same as 35%. And that's your answer to the question. For the first part of this question, we need to find the city with the lowest temperature. If you're struggling to do this, then a number line will be helpful. Let's mark on each of the cities. We have Manchester at 8 degrees C, London's at -2, and Birmingham -3. You can see from this, Birmingham is furthest to the left, so that must be the city with the lowest temperature. So the answer is Birmingham. For the next part of this question, we need to work out the range of the temperatures. The range is the biggest take away the smallest. So the greatest temperature here is 8 degrees C, and we subtract from that the smallest temperature, which was Birmingham's at -3. When you subtract a negative number, that's just like adding, so we need to do 8 plus 3, which gives you 11. You can also see that visually if we look at the number line. The difference here between the -3 and the 8 is 11 spaces. In the final part of this question, we're asked to work out the mean temperature. To do this, we need to add together all of the temperatures we have and divide them by how many there were. So we'll start with Manchester at 8, we'll add to this -2, and then add to this -3. This is just like doing 8 take away 2 take away 3, which gives you 3. Then we divide this by how many cities there were, which is 3, so 3 divided by 3 gives you 1. So the answer to the mean is 1 degree C. In this question, we need to write some times in order, but one of them's in minutes and 2 of them are in hours. So let's convert the ones from hours into minutes. Let's start with 1 1/3 hours. The tricky part here is the 1/3 hours. 1/3 of an hour means do 60 minutes, which is 1 hour, divided by 3. So 60 divided by 3 is 20 minutes. So 1/3 of an hour is 20 minutes. 1 hour itself is 60 minutes, so 1 1/3 hours must be 60 minutes plus 20 minutes, which is 80 minutes. Now let's look at 1.5 hours. Well, half an hour would just be 60 divided by 2, which gives you 30 minutes. And if we add that to the 1 hour, which is 60 minutes, 60 add 30 is 90 minutes. So we've got 100 minutes, 80 minutes, and 90 minutes. Clearly the smallest is 80 minutes, that was 1 1/3 hours. Then it's 90 minutes, which was 1.5 hours. And finally the 100 minutes. In this question, we need to find 130% of 600. We'll start by trying to find 10%. To find 10% of any number, you divide it by 10. So 600 divided by 10 is 60. Now we can multiply this by 3 to get to 30%. So 10% times 3 is 30%, and 60 times 3 is 180. Now 100% just means the whole number, so 100% is just 600. Now if we add together the 100% and the 30%, we must get 130%. So 180 plus 600 is 780. In this question, we're told that m and n are different prime numbers. So let's write down our prime numbers. These are numbers with exactly 2 factors, so 2, 3, 5, 7, 11, 13, 17, 19, and so on. Now we need to find a pair of these numbers that add together to give a square number. Square numbers are obtained when you times a number by itself, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, and so on. So we need to pick 2 numbers from the first list, the prime numbers, that add together to make 1 number from the second list, so the square numbers. So you could have, for example, 2 and 7, because these add together to make 9. That's not the only possibility though, you could have 3 and 13, and that makes 16. There are probably more of these, in fact if you find one, leave me a comment to let me know. Next we need to do the same process, but we're looking for a cube number. Cube numbers are obtained by multiplying a number by itself and then itself once more. So 3 times, so 1 times 1 times 1 is 1. 2 times 2 times 2 again is 8. 3 times 3 times 3 again is 27. 4 times 4 times 4 again, 64. 5 times 5 times 5 again, 125, and so on. So we're looking for 2 numbers from the first list that add together to give 1 in the second list. So for this one, I'm going to go for 3 and 5, since 3 and 5 add together to make 8. There may be some more of these, again if you find one, let me know in the comments. And for this final part, we need to pick 2 prime numbers that add together to make a triangular number. We can make triangular numbers by drawing out triangles. This looks a lot like the red balls on a snooker table. So we start with 1 ball, so 1. Then we add the next row, so 2 more balls, which makes 3 balls total. Then we add another row, so that's 3 more, which makes 6 balls total. Another row, so 4 more, which makes 10 balls total. And then another row, that's 15 total. And then another, 21 total. And you can carry on like this. So we need 2 numbers from the top list to make one in the bottom list. For this one, I've gone for 3 and 7. 3 and 7 adds together to make 10. You may also have gone for this one, so you could have 2 and 13. Or even 2 and 19. Again, there may be even more than this, so if you find one, let me know in the comments. For this question, we need to write a ratio, so the area of shape A to the area of shape B. Shape A is a parallelogram, so to find its area, we need its base and perpendicular height. So the base here is 5 squares across, so 5 centimeters, and the perpendicular height here, we can count that, that's 4 squares, so 4 centimeters. So all you do for a parallelogram is just times those together, so 5 times 4, which is 20. Shape B is a trapezium, so we need to know the length of its parallel sides and also its height. The parallel sides here are the bottom and the top side, so if we find those, that will be 6 on the bottom here, and 2 squares on the top. We also need the perpendicular height, which once again is 4. We can now use the formula for the area of a trapezium, which is 1/2 times the sum of the parallel sides, so that's the 2 and the 6, so 2 plus 6, times the perpendicular height, which is 4. If we add together the 2 and the 6 here, we get 8, so it's half of 8 times 4. Now you can do half of 8, that's 4, and times that by 4 gives you 4 times 4, which is 16. So we found the areas of shape A and shape B is 20 and 16. So if we write that in a ratio like this, and then the question does say to give your answer in simplest form, so we'll divide both of those by 4. 20 divided by 4 is 5, and 16 divided by 4 is 4. So the final answer to this question is 5:4. In this question, we're told that the 2p coin has a greater circumference, and we need to work out by how much, giving our answer in terms of pi. So for this, we're going to use the formula for the circumference, which is circumference equals pi times diameter. Let's start with the 5p coin. So it says the 5p coin has a radius of 9mm. So if we draw out a circle, the radius of 9mm would look something like this. Now the formula for the circumference was pi times diameter, not pi times radius. So if we double that 9mm, we get the diameter, which is 18. So for the 5p coin, the circumference is pi times 18, which is 18 pi. Now let's have a look at the 2p. Well, the 2p has a diameter of 26mm, so it looks something like this. Now we can just go straight to the formula here since that's the diameter, so its circumference equals pi times 26, which is 26 pi. So we have the circumference for the 2p and the circumference for the 5p. To work out how much greater the one for the 2p is, we just subtract them. So 26 pi take away 18 pi gives you 8 pi. In this question, we have Samantha who has some money for her birthday, and she spends a quarter of it on a mobile phone and 2/7 on a coat. So if we add these two fractions together, we'll find the fraction of the money that she spends, so 1/4 plus 2/7. To add fractions, you need a common denominator. This case, 28 is probably the best choice. So we need to convert that 1/4 to 28ths. To do this, we'd multiply the top and bottom by 7. So 1 times 7 is 7 on the top, and 4 times 7 is 28 on the bottom. We also need to convert the 2/7 out of 28. To do this, we multiply the top and bottom by 4. So if we multiply the top by 4, 2 times 4 gives you 8, and the bottom, 7 times 4, is of course 28. Now that we have a common denominator, we can add them together. So it'll be something over 28, and to get the numerator, we add the 7 and the 8 on the top here, which gives you 15. So she spends 15 28ths of her money. So we need to work out how much she saves, which is the rest. So if we do 1 take away 15 over 28, we find the rest. Now the best way to think of a subtraction like this is how many more 28ths would we need to get from 15 28ths to get to 1 whole. So if you do 28 take away 15, you get 13, so the answer is 13 28ths. For this question, we're given the ratio of time that Gary spends revising English and Maths, and that's 5:3. So we could write down the ratio of English to Maths as 5:3. In the question, we're told that he spends 40 minutes revising for English, and we need to work out how long he revises for Maths for. So we can write the 40 minutes underneath the English, and then we need to work out how we get from 5 to 40. Well, that's multiplied by 8, so we'll multiply the 3 by 8 as well, which gives you 24. So the answer to the question is 24 minutes. For the next part of this question, we're given Phil's ratio, which is 1 to 3. So we can write down English to Maths, which is 1 to 3. But this time we're told Phil's total amount of revision time, which is 2 hours. So let's create a total column, and in there put the total amount of parts that we have. So we've got 1 part English, 3 parts Maths, which is 4 parts total. So 2 hours is 120 minutes, 2 times 60. So we write that underneath the total column because that's the total amount of revision he does. So how do we get from 4 to 120? Well, that's times by 30. So if we multiply the other parts of the ratio by 30, 1 times 30 is 30, and 3 times 30 is 90. So the question said how long does he revise Maths for, and we can see that's 90 minutes. For this question we have ABC, which is a straight line. You should know that the angles on a straight line add to make 180 degrees. So let's add up these two angles, so that'll be 2x plus 60, that's the big angle, add the smaller angle, which is 30, and that gives you 180. We can collect like terms here, 60 and 30 makes 90, so it's 2x plus 90 equals 180. And then we have an equation to solve to find x. We can do this by subtracting 90 from both sides. If you subtract it from the left, it will cancel the 90 that's already there, leaving you with 2x. And if you do it on the right, 180 take away 90 is 90. Now we can divide both sides by 2. If you divide 2x by 2, you just get 1x, and 90 divided by 2 is the answer, 45 degrees. In this question we have a bag which has blue, red or green counters, and we're told there are 6 blue counters. We are also told the probability of selecting a blue is 1/5. So we don't know how many counters are actually in the bag. So if we were to work out the probability of selecting a blue counter, we do 6 blue counters, divide by the total number of counters, which we don't know, so we'll call that a question mark for the minute. Then this would equal 1/5, we're told that in the question. So we need to think of a number that we could replace this question mark with, so that these fractions were the same. So to get from 1 to 6 here, we multiply by 6, so let's multiply the 5 by 6, which gives you 30. So there must be 30 counters in the bag in total. We know that 6 of these counters are blue, so if we do 30 take away 6, we find there are 24 other counters that we don't know about. These must be the greens and reds. Now we're also told in the question there are twice as many green counters as red counters. This means the ratio of green to red must be 2 to 1, since there are twice as many greens as reds. Now we know the total amount of counters for green and red, which is 24, so if we construct a total column here, we add the 2 and the 1 parts to make 3 parts and put the total 24 counters we're dealing with underneath the 3. To get from 3 to 24 you multiply by 8, so let's multiply the other parts of the ratio by 8, 2 8s are 16, and 1 times 8 is 8. So we're asked for the number of red counters in the question, so that's 8 counters. For this question we have a formula, cost equals 6d plus 25d, where d is the number of days. We're told that Fiona wants to hire the car for 6 days, so we just need to replace the d in the formula with 6. So we end up with cost equals 6d plus 25 lots of d, which is 25 times 6. Since we have a multiplication here, we need to do that before the addition, so it's cost equals 6d, then we'll do 25 times 6, which is 150. Then 60 plus 150 is £210. In the second part of this question, we still have the same formula, but this time we're told the cost for Rachel's hire. And we need to work out how many days she hires the car for. So we can replace the c, the cost in the formula, with 335. So it's not c equals, it's 335 equals 6d plus 25d, since we don't know the number of days. Now this is just an equation to solve. Let's subtract 60 from both sides. If you subtract it from the left, you get 275. And if you subtract it from the right, it will cancel the 60 that's already there, so we've just got 25d left. Now you can divide both sides by 25. Well, we know that 10 25s is 250, that's pretty close. We just need one more 25 to get 275. So on the left, 275 divide 25 is 11, and on the right it will cancel the 25 just to give you d, which is the number of days. So we know the answer is 11 days. In this question we need to tick the correct box for each of the statements. Let's start with the first statement. The modal number of pets is 4. To find the modal number of pets, you're looking for the number of pets that has the highest frequency. Now looking at the table, we've got 4 pets with a frequency of 2. 2 is not a very high frequency, so that's actually not the modal number of pets. You can see based on the information we already have that 1 pets has a frequency of 6, which is definitely higher. So whilst we don't know the actual mode yet because we don't know the frequency for 0, we can be sure 100% it's not going to be 4 since the frequency of that is very low, in fact it's just 2. So the answer to the first part is cannot be true. For the second part it says the minimum number of pets is 1. Now looking at the table we can see that 6 people had 1 pet, but we don't know how many people had 0 pets, so at the moment it looks like 1 pets is the lowest, but it really depends how many people had 0 pets. If 0 people had 0 pets, then the lowest would actually be 1 pet. However, it may not be 0, it could be any number, it could be 4. So if there were 4 people with 0 pets, the lowest number of pets would actually be 0, in which case it wouldn't be true. So for this statement it could be true, but it also might not be true, in which case we should tick the middle box, could be true. And for the final statement, the median number of pets is 1. The median number of pets will be the middle number of pets if we write them all out in order. So at the moment we know 6 people had 1 pet, so that means we'd have the number 1 6 times. We also have 4 people with 2 pets, so that's the number 2 4 times. 4 people had 3 pets, so that's the number 3 4 times. And we also had 2 people with 4 pets, so that's the number 4 2 times. But what we don't know is about the number 0. So it could be that there are 0 people with 0 pets, so we don't need a 0 in our list. Let's work out the median in this scenario. So we cross off the lowest and the greatest number in pairs like this until we reach the middle. And you can see the middle in this scenario is 2, in which case the median is not 1. But what about if we change this frequency for the 0 pets? What if it goes up to 4, like we had earlier? Well, in this case we'd have the same list, but we'd also have 4 zeros at the front. So if we cross off the numbers in pairs here again, until we end up with a middle number, you can see that in this situation we do end up with 1. So once again this could be true, because we can have some situations where it is true and some where it's not. In this question we have a rectangle, and we're told its area is 20 centimeters squared. For the first part of the question we're asked to find W if L equals 4. So let's label on the length being 4 centimeters and we need to find what the width is. So we just need to work out what we would multiply 4 by to get to 20. To do this we can just do 20 divided by 4, which gives you 5. For the second part of the question we have a rectangle again, but it will look a little bit different. So we've got the area of 20 centimeters squared again, but this time we're told to find W if the length is 0.5 centimeters. So something that looks like this. Once again we need to work out what we multiply 0.5 by to get 20, so we do 20 divided by 0.5. 0.5 is just the same as 1/2, so we need to see how many halves fit into 20. Now there are 2 halves in every hole, so each one of those holes will have 2 halves in it, and there are 20 of them, so we just do 20 times 2, which gives you 40. For the final part of this question we need to tick the correct statement. Since we were always multiplying the length and the width together to get a constant number of 20, we could say that W is inversely proportional to L. In this question we need to work out the distance from the bottom of the block to the bottom of the container. Let's label that distance on the diagram and call it x. The next thing to do is work out the distance from the water level to the top of the container, this one here. Now we can do this because we know the height of the container is 2 meters and we know the depth of the water is 1.3 meters, so if we subtract those, we'll find this length. So 2 meters take away 1.3 meters is 0.7 meters, which is the same as 70 centimeters, so we can label that on the diagram. Next we can find this length here, which is the amount of the block that's above the water level. We can do this because we know this amount plus the 34 centimeters must equal the 70 centimeters. So if we do 70 take away 34, we find it's 36. So we can label that onto our diagram as well. Next we're told in the question that 2/5 of the block is below the water level. So let's label this onto the diagram, so there's 2/5 below the water level, which means there must be 3/5 above the water level. But we know how much is above the water level, that's 36 centimeters. So 3/5 of the block is the same as 36 centimeters. If we divide both of these by 3, we can find the amount for 1/5. So 1/5 must equal 36 divided by 3, which is 12. Now 2/5 is below the water, so if we double this we'll get 2/5, and double 12 is 24. So we find the amount of the block that's underneath the water level is 24 centimeters. So we're nearly there now, so you can see this 24 centimeters plus the value x that we're trying to find must equal 1.3 meters because that's the depth of the water. So we can do 1.3 meters or 130 centimeters take away 24, which gives you 106, and that's the answer to the question. In this question we have a geometric progression. We're told the fourth term is 20 and the next term, the fifth term, is 40. To get from one term to the next term in the geometric progression, you must always be multiplying or dividing by the same number. So what do we do to get from 20 over to 40? Well, we're going to multiply by 2. So to get from 40 to the next term, which is the one we want to find, we just multiply by 2 as well, which will give you 80. And that's the answer to the question. For the second part of this question, we have an arithmetic progression. This means to get from one term to the next term, we're going to add or take away some constant number. So we're told the 9th term is 10 and the 10th term is 5. So what do we do to get from 10 over to 5? Well, in this case, it's take away 5. Now we need to find the 7th term this time, so we need to go backwards in the sequence, in fact backwards 2 terms. So to get from the 9th term back to the 8th term, we would actually add 5. This will put you on 15. And to get from the 8th term back to the 7th term, we need to add 5 again. And this will give you 20. So the answer to the question is 20. In this question, we need to write some numbers in standard form. The first part of standard form needs to be a number that's between 1 and 10. So for this number here, we'll need to pick 4.1. Then we multiply this by a power of 10. Now you can see in this question it's a very small number. So we'd actually need to divide 4.1 lots of times to end up with 0.00041. The question is, how many times would we need to do this? So let's start with 4.1. If we divide it by 10 once, we get 0.41. Divide it by 10 a second time, a third time, and then a fourth time, and we'd end up with our number. So since we divided it by 10 4 times, we need a negative power in the power of 10 in the standard form, so it would be times 10 to the power negative 4. For the next one, we need to do 3 million. That's a 3 with 6 zeros after it. So we need to start with a number from 1 to 10, so we'd go for 3. And then we times 10 to the power of something. So let's pop the decimal point here and start with the number 3.000000. That's just 3. If we times it by 10, we get 30. 10 again, we get 300. 10 again, again, and one more time, and we'd end up with 3 million. So that was 6 times, so it's 3 times 10 to the power 6. To start this question, I'm going to convert the numbers from standard form back to ordinary numbers. So let's start with a, which is 3.1 times 10 squared. That's 3.1, and 10 squared is 100, so 3.1 times 100, which is 310. For b, we have 6 times 10 to the power negative 1, so that's 6, and then since it's a negative power, we need to just divide it by 10 one time, so 6 divided by 10, which is 0.6. Now the question wants us to find 2a plus 3b. So let's do 2a first, which is 2 lots of a, and a is 310, so 2 lots of 310, which gives you 620. And then we need to do 3b, and we know b is 0.6, so 3 lots of 0.6, which is 1.8. So we just need to add together 2a and 3b, so add 620 and 1.8, and you get 621.8. This question is testing index laws. Let's look at the bottom of the fraction first. We've got 2 to the 8 times 2 to the negative 1. When you multiply like this, you add the indices, so we need to do 8, add negative 1. That's just the same as 8 take away 1, so that's 7. So this equals 2 to the power 7. Now on the top we have 2 to the power 10, and then divide by 2 to the power 7. So when we divide like this, we subtract the indices. So we need to do 10 take away 7, which is 3. So this is 2 to the power 3. Now we're asked to work out the value in this question, not write it as a power of 2. So we need to do 2 cubed, which is 2 times 2 times 2 once more, which gives you 8. For this question, we're asked to use approximations to estimate the value. This means we're going to round all of the numbers in the question to make the calculation a little bit easier. So instead of 311, we'd round that to 300. Instead of 19, we'd round that to 20. And instead of 0.21, we could round that to 0.2. Now we can work this out. So 300 times 20 on the top, we just do 3 times 2, which is 6. And then we've got 3 more zeros, so 6,000. On the bottom we need to do 0.2 times 0.2, which is 0.04. Now this is quite difficult to do in its current form because it's got a decimal on the bottom. So if we multiply the top and bottom by 100, that will remove that decimal. So if we multiply the bottom by 100, we get 4, and if you multiply the top by 100, 6,000 becomes 600,000. So this will give us the same answer. So we just need to do 600,000 divided by 4. It's probably best to do a bus stop for that. So 600,000 divided by 4. 4s into 6 goes 1 time with 2 left over. 4s into 20 goes 5 times, and then it's just 0, 0, 0, 0. So the answer to this question, 150,000. Thank you for watching this video, I hope you found it useful. I've put some suggested grade boundaries here based on previous years, but remember we won't know the real grade boundaries until the exams are actually done. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.